Great. So hi, I'm Ianna Osborne. I'm a research software engineer with Princeton and PyHEP, and my background is in physics and computer science. And I work with Jim on awkward array, and this is our new development where I'm really pleased to present this connection of awkward and RDataFrame. So when we look at the awkward array and RDataFrame, they're two very different ways of performing calculations, large-scale calculations. And as Alex has shown just recently, just in previous talk, what we can do with awkward array is in a typical workflow, when you get columnar data served by service X or uproot, then you present users sees them as awkward arrays and does selection, event selection, applies systematics, so on and so forth, produces histograms and so forth. And the RDataFrame is a declarative analysis interface, and it actually reads from columnar data format via DataSource, and it supports many input formats. I'm not going to go into the details what those projects are. I'm sure that you, most of you know by now already what awkward array is, and except for those two things, they are quite different, but in a way that now we have the bridge that provides users with more flexibility in mixing those different packages and languages in their analysis. So there are numerous benefits in combining both C++ and Python, and let's try to do this on a small example where we take awkward arrays, put them in RDataFrame, perform some analysis there, and for users who actually do have preference for C++ root and analysis in RDataFrame, exporting those some data to awkward array can open multiple paths of using other tools in Python ecosystem. There were several talks I mentioned here. Links are available, which were presented at this workshop. And there will be two more tomorrow, Dax and Kush's, how awkward arrays are used with Dask and uproot. So let's start from awkward array to RDataFrame. This module is part of awkward array version 2, which is currently a submodule. So we import awkward array, and we need also root. Let's define a typical, very simple array of records and the array of lists, and just a flat array. So when we check the types of the arrays, we can see that they are variable length arrays for these records, and for the list as well. And all those three arrays have the same length. So this is the requirement for the two RDataFrame function, which is an awkward style function. So it takes a dictionary, and this dictionary has a key, which will become the column in RDataFrame and the awkward array. So each key has to be unique. The lengths of all arrays have to be the same. So when we execute this function, we have a data frame, and we can actually look at the state by asking to describe itself and print the information. So we can see the columns. What are the columns? What are the column names? And what is the column type and the origin? So we put into the RDataFrame three arrays. So the origin is dataset, and one column is defined, so don't worry about that. It's just used internally for filtering. And you can see that the record array has a very strange, awkward type. It's kind of hashed because the awkward arrays are dynamically typed. And in fact, we don't need to know the type because we can use the placeholder type specifier auto. So we'll just get all the needed information when we actually use this records. And the list arrays actually are converted to RVex, and you can see that this is the type which is native to RDataFrame. So the I should mention that the data is not copied. The same information we can get from DataFrame about the column types, and it will return the strings of the array for the column types for X, Y, and Z. And now we can schedule some operations on our data frame. For example, we can ask the data frame to filter all columns on the column Y, where the values of this array are greater than 2. And let's check that the data frame didn't trigger the event loop, because this is something we want to avoid. It can be a very costly operation to run the event loop on all the data. So usually scheduling these operations doesn't trigger it, and we ask to describe and print again, and we can see that we have the same number of columns, and the event loop was not actually run. What can we do now with the data frame? Let's take some this data out as awkward arrays, and we provide the function from our data frame that can take selected columns and convert them to native awkward arrays. So this function takes a tuple of strings, which are the RDF column names, and the event loop, the RDF event loop, is triggered only once to retrieve all selected columns at once. So the result of it is, we can see it's an awkward array. And let's check the type, whether actually it was filtered. We also use the show with the parameter to show the type. And we can see that the type of this array, it contains records. This one is slightly weird because we put records with the field X in the column X. So we had 3 columns in our data frame which were retrieved, Y, Z, and X, and the types seem to be correct. And also, let's check the values that actually we did get them filtered with the Y greater than 2. And we print the results of the column Y, which is correct. And you can see that the other fields are also returned as filtered based on that, because so now we can actually check again. You know, this is what I'm getting obsessed with, the whether we run event loop or not. And the event loop was run only once. And so that's and the same information about the columns. So nothing changed there. For slightly deeper information about how the data is copied or not, you can see a look at the layout. This is usually something users will not do, but just to make sure that we actually had this record array with all the values, and you can see that the array which we took out of the R data frame still has all these values, but this record array is indexed. So we don't see the values which didn't match the selection, but the values are still there. However, if we look at the list of set array and flat array, we can see that the values were actually copied. So in this case, we lost the original information that this data came from the awkward array, and it became RVec, so we actually copied them back. So we can do the same operation on awkward arrays in Python just to make sure that we get the correct results and check that the type is expected. So we can create an array of all these 3 arrays and filter it on the field on the record Y with the values greater than 2 and check the type. You can see that the type is exactly the same. However, if we look at the layout is different, because in this case, we didn't change any of the records at all. So the indexed, values of the records were indexed at the very top. It's because the awkward arrays are actually immutable. So when we go from RDataFrame to awkward array, this function from RDataFrame converts selected columns to native awkward arrays. And the function takes a tuple of strings that are columns and recognizes the following column types. So the primitive types, like integer, float, what you can see in this table in green. And so actually the Python types, you can see this in blue. When we have an array type of NumPy type of a primitive type, it will be translated into the vector of a primitive type, or actually we can have array type of a list type nested multiple times, and then a NumPy type of primitive type. So this in C++, it will be converted to nested vectors or nested RVecs of these types. And all these types are supported except for datetime, time delta, and Boolean. Awkward types that are runtime generated, those are derived from awkward array view or awkward record view. They are not copied because awkward arrays are immutable. So let's try a small data analysis, and we'll go from C++ to Python. We'll take CMS open data for that contains some muon collection of NaN-IIDs. So this data set is called events in the file, and it contains number of muons in the event, transverse momentum, pseudo-rapidity, azimuth, mass, and charge of the muons. And let's see, we'll just give this file to the RDataFrame, and RDataFrame is capable of reading remote files, and in this case, it's my local file, and we can check the state of the data frame. So you can see all these columns were read from the data set. So we can have we have vectors of floats and integers, and number of muons as just an integer. And let's build a small analysis studying the invariant mass of this dimuon system. I put a link to the root tutorial for more information. And so for the RDataFrame, we can schedule some operations. They will not trigger the event loop, but we want to have the records with the columns with number of muons to 2 with an opposite charge. We'll define the dimuon mass by applying the function, which is also provided by root on those 4 columns. And then we filter again for dimuon mass of greater than 70 GeV, and we'll take only 1,000 records of that. So the event loop is triggered only when we actually ask the mean value of the dimuon mass. And this is something to remember. This is our baseline. we get the approximate mass of the Z boson of 91.44 GeV. And to make sure that the operation is triggered only once, we ask the data frame to describe itself, and we can see that the event loop is run only once. And now we can also see that we have additional column, diamond mass, which was defined, which didn't come from the data set. How about we convert some selected columns to awkward array? So we've done all this analysis, and now we're interested in taking this diamond mass column and do some maybe nice things in the Python world, like plotting, and maybe just continuing analysis with the other packages. So as we have seen that the scheduled analysis executed event loop only once, the user takes data out as an awkward array using from RDataFrame function. It selects diamond months column, and we get awkward array, thousands lengths. We can look at the array type and see that it's just the bunch of floats, and this is something we want to check again, that the event loop was run one more time. So we have run the event loop twice, one for analysis and one for taking the data out as awkward array. Then now we have data as awkward arrays in Python, and what we can do with them, Alexander, you can see Alexander's talk or James' talk, and in this tutorial, we just plot those with the hist. And we can see a nice distribution. Or we can just say, okay, let's double check and use it NumPy and check the mean of this diamond mass, which is exactly the same number as we got before with the analysis on the RDataFrame with the root function. Now we'll try to do a round trip, and we will use the same file, which is about 60 million events. And in principle, we can enable the multi-threading with the enable implicit multi-threading, and then we'll just take all of the events as awkward array, and we'll take all the columns which are in this file. We can see that we have the awkward array of about 60 million records, and the type of this awkward array has all these jagged records, and you can see that some of them have 2 muons, some of them have 1, and 4, all this variation. So what can we do with that? Let's put it back in our data frame. And we'll just put it back as a single column events. And it doesn't take much time whatsoever. And when we check the data frame, we can see that the event loop was not run. And we have the column, which comes from the data set, and it's awkward type, which is a record. So how do we deal with this column now? Because we know that this type is awkward record, but we want to access actually the records of this, the fields of this record. So we can use the functions, which is the function is exactly the same as the function's name is the same as the field name of the original record array. So if we look what was the what were the fields of this array. So now we can access the data from this column as events, as we put the column events, column name, and the field record field name. And those functions will return an iterable object. In fact, it's going to be rvec, and an integer index can be used to access the elements of the records. Like, for example, here, when we want to have a muon charge of the first muon. And the same invariant mass C++ function can be applied to define a new dimuon mass column. So we can see that we'll do the same. We'll do the same selection. We'll want to have two muons. We want to have muons of opposite charge, and we define the new column of dimuon mass with the invariant mass function, which comes from root, and the parameters of this function, the arguments, are going to be the records of the awkward array, which is in RDataFrame. So we'll take muon pt, muon eta, phi, and mass. And finally, we'll just say we want to have dimuon mass, which is greater than 70, and a range of only 1,000 records. So we schedule this analysis. The event, checking again the event loop run only once, and we have now new column, which came from define, and when we ask to print it, we get exactly the same number, 91.44 GeV. Okay, so now we know how to use awkward arrays in RDataFrame. Let's define our own invariant mass function that takes an awkward type. And we can actually write a lambda function and give it to the define. So in this case, I'm doing the same pre-selection, just using the same. We could put the if statements here in the code, but it's going to be less efficient. And you can try it in your environment. You can try to run the notebook yourself and check whether it makes difference. And I bet that RDataFrame will filter. It's much faster than even the C++ code which you provide. So in this case, we scheduled the analysis with our own lambda function. We asked the data frame to describe itself, and the event loop ran only once. We have this dimuon mass column now, which we just defined. And when we ask for the mean, we get exactly the same 91.44 GeV. So in this case, I didn't filter post-define, so I had to add the filter on dimuon mass greater than 70, and also take the range of 1,000, because actually in this case we have 60 million records. Let's check that the result is actually the same by taking out the dimuon mass from the RDataFrame as awkward array, and we get this result. And we select again that we want to have only those which are greater than 70 GeV, and calculate the mean using NumPy, which gives us exactly the same result, 91.44. We can go even further and define C++ functions. You can do it either like here in your code or in the header file. And this is pretty much, you can recognize it's a copy of the function which root provides with slight variations that we can define, say, use different type. In this case, we schedule, the only sort of downside is that you can only define a function once. So if you put this function, if you define this function and then you just say, okay, but now I have to change something and I want to do modify the body, you would need to rename it, and because when we give it to the interpreter here, to the compiler, it puts it in the global namespace, so it just slight downside of that. Nevertheless, we can apply the same analysis to the data frame now with your own defined function. And you can see that, as I said before, the records are actually recognized as RVEX. And we schedule the analysis and we ask for the mean value and we get exactly the same result. So if this is slightly awkward, you may want to say, okay, I don't want to have awkward types in my RDataFrame. In this case, you can place the records as native RVEX. And for that, we just ask awkward array to provide us single records, and then we place them as different columns in the data frame. Again, after we put it into the data frame, we can check, and now we can see that the columns are actually native RVEX. And after that, you can also apply the same function on RVEX and get exactly the same result. So in summary, awkward arrays and RDataFrame provide two very different ways of performing large-scale calculations. And I hope that you will benefit from using both of them. And this awkward RDF bridge actually is part of version 2, which is currently a submodule. And the awkward version 2 will be released at the beginning of December 2020. If you want to see the timeline, it's here. And your feedback is greatly appreciated. Please report issues and ask for any features if you feel that it's something is missing.